Hey, today we will discuss the third module of your topic, joint distribution. We have already discussed some topics in this module like joint distribution, marginal distribution and expectation, like that. We will have a quick revision on this matter. The module contains joint distributions, discrete joint distributions, continuous joint distributions and marginal distribution independent random variables. These topics we cover on this lecture, and the remaining topics like expectation, covariance and central limit theorem we will discuss in coming lectures. Okay. What is a joint distribution? The joint distribution is nothing but a probability distribution of more than one variable. That's all. Okay. Even though the definition is have x, y, etc. defined on probability space, the joint probability distribution of x, y is probability distribution that gives probability that each of x, y falls in a particular range of discrete set of value specified for that variable. The definition is like this, but the only meaning of that definition is that the probability distribution function, if it contains more than one random variable, then it is called joint distribution. That's all. If it is of one variable, then it is a single variable distribution and it's not a joint distribution. So there are two types of joint distributions. One is discrete joint distribution, that is joint probability mass function, and the other one is if the variables are continuous, we call it is what? A joint density function. Okay. In discrete case, we express that joint distribution in this matter, that is probability mass function in this matter, x, y takes these values and x takes these values. The body of the table gives corresponding probability. That's all. So if x equal to 0 and y equal to 0, then the probability is 1 by 2, and the probability of x equal to 1 and y equal to 1 is 1 by 8, like that. The only thing, check x equal to this one, x takes these values and y takes these values, and if corresponding probability will be given in table. And you know that in continuous case it is not possible to express in table. You need to express it as a function, which is called joint density function. Okay. Joint density function is a function from R square to R square is xy plane. There only that xy ordered pairs lies. And then x r square to r, this to represent the probability that a belongs to r square. We should get the probability like this. So one thing you should notice, in continuous case you should always integrate to get the probability. You cannot directly take probability from a continuous distribution. Okay. So for example, if this is a distribution f of xy equal to 1, 0 less than x less than 1, it doesn't mean the probability of a point is 1. Okay. It does means that if you integrate this on a specific area, you will get the probability of that area. On a single point, the probability will be always 0. In continuous distributions, as we already knows that the single point probability will be 0. So, and another thing, this number can be greater than 1 depending on this range. Okay, if this 0 less than x less than 1 by 2, 0 less than y less than 1 by 2, then this can be actually 4. Okay. The only thing is that the total probability should be 1, and if we integrate this in this range, it should get 1. So this very much correct that even if f of xy greater than 1, you may get a probability less than 1. The only thing is that if you integrate in this area, you should get 1. So any subset of this area, if we integrate this function, you will always get 1. Okay. Always get less than 1. Okay. So you should integrate in order to get the probability. Okay. So what is marginal distribution? We know that what is joint distributions. So joint distribution contain more than one variable. So you know, if there are two variables there will be a probability associated with one variable. So the method of finding a probability of one variable from the joint distribution of two or more variables is called marginalization, and the resulting function is called marginal distribution. So after getting marginalization, calculating this one, you will get a function like this, y only. There will be no reference to x. Okay, there is no x at all. So in this case, you need to sum up this in this way. In discrete distribution, it is very easy. You need to sum in row wise in order to get fx of x, and column wise in order to get fy of y. And the values lie in margin. It's the marginal distribution. Okay, so the margin distribution is like this: y fy of y equal to c with respect for 0, y equal to 0, it will be 5 by 8. For 1, it will be 3 by 8. You need to, this only represent that sigma over y, sigma over x we are doing in order to get fy of y. X means this is y values. So with respect to x, if we are doing that, you will get this 5 by 8, and which is marginal distribution. Okay. In case of continuous case, you need to integrate. Of course, in continuous case, you should always integrate. Okay. If fx, in order to get the marginal distribution of x, you need to integrate over y in the range y, with respect to y in the range y. Okay. If f of xy equal to 1 by 96xy, 0 less than x less than 4, 1 less than x, y less than 4, in order to get the marginal distribution of x, fx of x equal to integral over y, fx of y dy. If you integrate over y, you can notice that if we integrate on y and give limits, the y get eliminated and it will be a function of x, then which is called marginal distribution of x. Integral 1, here the range of y is 1 to 5, 1 to 5, 1 by 96 xy, that is f of xy, and you get x by x. So x by 8 is the marginal distribution of x. Now, independence of random variable. Two random variables x and y are independent if knowing the value of them does not change, one of them does not change the probability of the other. Okay, what does it mean by independence? Independent means one thing is not related to other, or the change in one thing will not be reflected on other. Okay, for example, the wind speed, okay, is a essential variable in predicting rain. So wind speed and rain are not independent. Okay, so likewise many things are like that. Wind speed, temperature, and all these things are dependent variable if we compare to what, rain, predicting rain. Okay, let's take another example. And the way how we check whether two variables are independent is if the joint distribution is product of marginals. This is joint distribution f of xy equal to the marginals is f1 of x into f1 of x is marginal distribution of x and f2 of y is marginal distribution of y. If this product is equal to f of xy, then the x and y are independent. For example, the event of getting 6, let's consider an example. The event of getting 6 on the first time a die rolled, and the event of getting a 6 in second time a die rolled is independent. Okay, now consider a die is rolled twice. The outcome of first die will not have any impact on the second die. So irrespective of whatever the outcome of first die, the second die getting a 6 on second die will be 1 by 6. There is no effect on first die. Okay, that's why both are independent. Getting a 6 on first die will be independent of getting a 6 on second die. That's all. Okay. In contrast, the event of getting a 6 first time a die rolled and the event of getting the sum of the numbers seen on the first and second trial is 8 are not independent. So what is this? On first day we should get 8. Okay, that is x. If x equal to 1, then the first day, if the first day it appears as 6, then x equal to 1. That is success for x. X have a success and failure. Success is x equal to 1, which is getting a 6 on first day. Okay. Likewise, x equal to 0. Actually, if the experiment fails, then first day may have 0, 1, 2, 3 up to 5, except x 6, except 6. Okay. And what is y? Y depends defines the event that the sum of two dice, or a die is rolled twice, then sum of this die rolling should be 8. So when we consider the random variable y, then y equal to 1, that is success. Y equal to 1 will be success is only if the sum of two dice should be 8. Okay, all other numbers 1, 2, 4, 5, etc. If the sum is 2, 4, 5, then y equal to 0. Anything else will be 0. So let's go how the random variables are defined. That x equal to 1 if getting 6 on the first day, that is success, and 0 otherwise. Anything else will be a failure, that is x equal to 0. Therefore probability of x equal to 1, that getting a 6 on first day, that is there are 6 phases, therefore 1 by 6 will be probability of getting a 6 on first day. Unless y equal to 1 if getting sum of 8 on the first day, and on the first and second day. Okay, so we have to roll 2 dice and the sum should be 8, then only it will be considered as a success, or y equal to 1. If the sum is anything else except 8, 2, 3, 4, 10, etc., then y equal to 0. Okay, now let us check whether these are independent or not. Now when probability of y equal to 1, probability of y equal to 1 means the sum of two dice should be 8. So if the outcome of first die is 2, then second die should show a 6 in order to get 8. So 2 plus 6 will be a success, 3 plus 5 will be a success, 4 plus 4 will be a success, 5 plus 3 will be 8, that is success, and 6 plus 2, that is also a success. These are success events. And all other events, like anything except 2 plus 1, that is equal to 3, will be a failure, because the sum should be 8, then only y equal to 1. Therefore the probability will be 1, 2, 3, 4, 5. 5 outcomes will be success, and total outcomes will be any 6 numbers can be appear on first day into any 6 number in second day. So 6 into 6 equal to 36. So the probability of x equal to 1 equal to 1 by 6, and probability of y equal to 1 equal to 5 by 6. Let's check probability of x equal to 1 and y equal to 1. X equal to 1 and y equal to 1. So what does it mean? So x equal to 1 means we need a success in first trial. Okay, and y equal to 1 means sum of the two trials should be 8. So probability of this is the only event possible, because sum should be 8 and first number should be success. All these events, other events, is failure, because first number is not 6, first number is not 6, first is not 6. So these are failure. So x equal to, corresponding to x equal to 0. So probability of this event is, this is the only event, so 1 divided by total number of expected outcomes, 1 by 36. So it is clear that if you multiply these two, you won't get this. 1 by 6 into 5 by 36 will not be 1 by 36. 1 by 6 into 5 by 36 cannot be 1 by 36. Therefore probability of x equal to 1, y equal to 1 not equal to probability of x equal to 1 and y equal to into probability of y equal to 1. Let's check another case, a discrete case. This is the discrete distribution table, and we have calculated already marginal distribution by summing up 1 by 2 plus 1 by 4 equal to 3 by 4, 1 by 8 plus 1 by 8 equal to 1 by 4, and marginal of y also in this form. Here I am using f1 of x and f2 of y to get the notation simplified. Fx of x, if we are writing, there will be sort of, I prefer to write in this way. Okay, it's just a notation. So here we are checking this number, whether f of x equal to 0, y equal to 0. X equal to 0, y equal to 0 probability is 1 by 2, but f1 of x equal to, that is first probability, 3 by 4. f1 of 1 equal to 1 by 4, 3 by 4, and f2 of 0 equal to 5 by 8. If you multiply these two, you won't get this one. For a discrete distribution, if the marginals are multiplied, you should get the corresponding number. If 3 by 4 and these two numbers are multiplied, you should get this one. Then only this variables will be independent. In case this should be product of this one, this two, and this should be a product of these two, etc. All these things should be satisfied. Even one is violated, then one cannot only violate, at least two should be violated. So even if one is violated, then also it's not independent. Here this clearly violates this 5 by 8 and 3 by 4 not equal to 1 by 2. That is, therefore f of 0 0 is not equal to f1 of 0 and f2 0. Hence it is not independent. Let's go to a continuous case. Let f of xy equal to 1 by 6xy, 0 less than x less than 4, 1 less than y less than 5. Then the marginal distribution f1 of x equal to x by 8 and f2 of x y equal to y by 12. Here f of xy equal to f1 of x into f2 of y. So check the multiply this one, f1 of x equal to x by 8 and f2 of y equal to x by 12, y by 12. If you multiply this one, xy divided by 8 into 12 is 96, that is xy divided by 96. You will get that. Therefore x and y are independent. Another example, given a joint probability density function of xy as f of xy equal to 8xy, 0 less than y less than x less than 1, show that x and y are independent and find x plus y equal to 1. Okay, the function is f of xy equal to 8xy, 0 less than y less than x less than 1. See this one, this 0 less than y less than x less than 1 is not equivalent to 0 less than y less than 1 and 0 less than x less than 1. This condition should satisfy y less than x. So we need to sketch this area. Actually, in order to get the correct how the distribution look like, we need to sketch this area. Okay, so how to sketch this area? This 0 less than x less y less than x less than 1 means both x and y are less than 1. So this area should lie in 0 1 0 1 square, and another condition should satisfy y less than x. How to know y less than 1? So we need to sketch the straight line y equal to 1, and under the area y you will get y less than x. So the area will be like this. If we sketch this square, and this is y equal to x, below that this area is given here. So only this area have probability, all other area here and anywhere else probability will be 0. First of all we should understand that. Then to attack first question, we need to check whether x and y are independent. For checking x and y are independent, we need to calculate marginals. How to calculate marginals? We need to calculate marginals of x. In order to calculate the marginal of x, we need to integrate this function with respect to y. Okay, let's calculate the marginal of f1 of x. Marginal f1 of x. So marginal of x is integral over y with respect to y. Okay, so we are substituting x and y. And how to get this range over y? You need to go for multiple integration first semester. topics. If anyone have any doubt in this topic, I am also uploading the slides of the multiple integral. Go to that slides and brush up that idea of multiple integration, how to give limits, how to check first what type 1 region, type 2 region, and how to give double integral limits, etc. You need double integral limits in this module, maybe next module also, I don't remember that exactly. Okay, anyway, in this module you need multiple integral limits. Here this is the area, so in this area you need to find the range of y is that this can be, this will be y part, and this, what we do only this, put a straight line here, draw a straight line here, and the minimum will be on x equal to 0, y equal to 0, y equal to 0 is x axis, y equal to 0, and maximum will be on the y equal to x straight line, that is equal to y equal to x, given this 0 to x 8xy dy. So when we integrate that, then 4x y square by, you know, multiple integration, so what will be there, x will be treated as constant with respect to y, so y square by 2 and 0 to x, then what will be 4x cube will be f1 of x, that is f1 of x equal to 4x cube, and the the range of x is 0 to 1, and similarly f2 of y equal to integral over x f of xy dx, that is integral, you know how to check this integral of x. Integral of x is from this line to this line, okay, that is from y to 1, from y to 1 we are integrating that 4xy, and you will get if you integrate that thing, 4x into 1 minus y square, if 0 less than y less than 1, 0 otherwise, all other positions will be 0. So it's clearly that 4x cube into 4x into 1 minus y square is not equal to 8xy, therefore this f of xy equal not equal to f1 of x into f2 of y. So these are not independent, x and y are not independent. Let's go for next part, probability of x plus y greater than 1. Okay, probability of x plus y greater than 1 is double integral. This is the x plus y greater than 1. X plus y greater than 1, how we draw x plus 1 greater than 1? This is the old sketch, and in order to include this x plus y greater than 1, what we do, we draw the straight line x plus y equal to 1. This straight line is x plus y equal to 1, and greater than 1 means above this, in between this area, this is the area what we want. Okay, in this area we need to calculate the probability. Double integral r f of xy dy, that is equal to, you know, from double integral it is what we should do, this x y limits we are considering is here as type 1 region, that is first integral is over y. So the limit is from, this is 1 by 2, okay, 1 by 2 to 1, this is limit, inner limit is 1 minus x from here to here, 1 minus x to x, here to here, 1 minus x is this straight line, and this straight line is x, 1 minus x, this limit is given by this straight line here, draw a straight line here, minimum to maximum, that is x, 1 minus x to x, and the outer integral will be the minimum and maximum of x, we are integrating over x, the minimum x value will be 1 by 2, half of this half will be 1 by 2 to x equal to 1, so 1 by 2 to 1. If we integrate that x 4xy, 4x is constant and y we are integrating and substituting values, we will get 1 by 2 to 1, 4x into 2x minus 1, and substituting values we will get 5 by 6. That's the way to calculate. So in this kind of problems, first we should find the region where the probabilities lies, that is this part, this graph, here only the probability lies from this range. And next we need to calculate, where the probability we need to calculate. So this one will be an area, and the intersection of this one and that one will be this region. So like that there will be a region, intersection of both. That in that area only we need to integrate. That is the R integration. And effect correspondingly find the limits and integrate. Okay. And you will get 5 by 6. Okay. That's all for today. Okay. And I repeat, if you have any problem in double integration, I am sharing my slides on that first tier multiple integral module. You may check that. You need only double integral, you don't need triple integral. You check that slides and brush up your knowledge. Anyway, you learned it from first semester. I know you all know, but maybe you need to brush up it. Okay. Thank you. We'll meet on next exam.